Dear students, in this video, the topic is sequences, and for Karnataka University BSc 4th SEM, this is the paper 1, sequences and series. In this video, I explain these things. I start with definition, what is a sequence, some examples, and what is bounded and unbounded sequences, what are bounded and unbounded sequences, and when do we say that sequence is convergent and divergent. First of all, what is a sequence? In the general sense, sequence means anything that is placed in some definite order. In the general sense, anything that is placed in, if you place some objects or anything in some definite order, then it is called a sequence. But we cannot say the definition like this. Definition means it is like this. Sequence means from schools you have studied what is a sequence. But here sequence means we consider only infinite sequence. Sequence means infinite. How the sequence is defined? Sequence means it is a function from set of naturals to set of reals. So the definition is sequence is it is a function from natural numbers to reals. Function is denoted by f. Now the important thing is the domain of this function is natural numbers, and codomain may be real number or subset of real, any real number. So the definition is like this. Sequence is a function from set of natural numbers to set of reals. So how the sequence we denote the sequence by different notations. We denote the sequence by un or sn or xn and so on. And also a sequence is denoted by its nth term. A sequence is denoted by its nth term. I give example here. Suppose u from n to r is defined by u of n is 1 upon n. I take one example here. U of n is 1 upon n. Then the function is defined like this. It is set of naturals to set of reals. Now I take the images here. N takes values only natural numbers. Take n is 1. What do you get? 1. N is 2. 1 by 2. 1 by 3. 1 by 4. And so on. Now this is infinite. Here we have written here images. And this is also one method of representing the sequence. So sequence is denoted by these notations un, sn, xn or an and so on. Different notations are used here. And what is the sequence? It is a function from natural numbers to reals. This is one example. Very simple way of writing the sequence is, if you write any expression in n, then it becomes a sequence. Say I have taken un is 1 upon n. Actually the function is defined like this. U is a function from n to r, and it is defined by u of n is 1 upon n. Then what are the images? 1 half, 1 by 3, 1 by 4 and so on. This is another method of representing a sequence. In primary schools or high schools you have studied sequence by this. You have denoted or you have written a sequence by its images. This is one example. But the definition of sequence is this. Sequence means it is a function from set of natural numbers to set of reals. That is the definition. I take some more examples here. First example is sequence un, where un is 1 upon n. Sequence un where un is n. sequence un, where un is the nth term. We denote or we know the sequence if its nth term is known, because n takes only natural numbers here. Un is n by n plus 1. Sometimes sequence is denoted by Sn also, so I use this notation also. Sequence Sn, where Sn is n square. Sequence Sn, where Sn is minus 1 raised to n. Sequence Sn, where Sn is minus 1 raised to n into n. These are some examples. Now what are the terms of the sequence here? See, always sequence means we consider only infinite sequences. 1 upon n means 1, 1 by 2, 1 by 3, 1 by 4 and so on. N means 1, 2, 3, 4 and so on. N by n plus 1 means if you take n is 1, you will get 1 by 2, 2 by 3, 3 by 4 and so on. N square means what is the sequence? 1, 2 square 4, 9, 16 and so on. Minus 1 raised to n, this is sequence important. Minus 1 raised to n means minus 1 1, minus 1 1, minus 1 1 and so on. And minus 1 raised to n into n, so it is minus 1 and plus 2, because n is 2, n is 3 gives again minus 3, n is 4 gives plus 4 and so on. Am I correct? These are example for sequences. So sequence means how to define? It is a function from set of natural numbers to reals. These are some examples. Next comes boundedness of a sequence. Boundedness. When do you say that sequence is bounded? First I'll take sequence which is bounded above. When do you say that sequence is bounded above? Bounded above. A sequence Sn is said to be bounded above if there exists k, real number k, so that Sn is less than k for all n. For all n. Then we say that sequence Sn is bounded above. That means if you take any member of that sequence, that must be less than some fixed real number. Fixed real number. Then we say that sequence is bounded above. Similarly, a sequence Sn is said to be bounded below if there exists any real number k, so that Sn is greater than k for all n. For all n. Sequence is said to be bounded above, bounded below. And a sequence is said to be bounded if it is bounded above as well as below. As well as below. Or a sequence is said to be bounded if mod Sn is less than or equal to k. Mod Sn is less than or equal to k. That means Sn is greater than minus k, less than or equal to k. Greater than or equal to minus k, less than or equal to k. Then we say that sequence is bounded. So when do you say that sequence is bounded? Sequence is bounded means it is bounded below as well as above. Sometimes it is taken like this, Sn less than or equal to k. Let us take like this, less than or equal to k. Now see this sequence, un is 1 upon n. Is it bounded? This sequence is bounded because what are the bounds of this sequence? Here k is called bound of the sequence, upper bound, small k is called lower bound of the sequence. Now this un is 1 upon n. Why it is bounded? 1 upon n is bounded because for all n, un is greater than or equal to 0, less than or equal to 1. Or I take un is greater than 0, less than or equal to 1. Correct? Un is less than or equal to 1, because n is 1, it becomes 1. Then slowly it decreases. The terms of the sequences are terms of the sequence is decreasing here. Then next we will come across when we say that sequence is increasing, decreasing, and monotonically increasing, monotonically decreasing sequence. That is a different topic. When we proceed, we will come across that also, monotonically increasing and decreasing sequences. Now, this sequence is bounded because less than or equal to 1, greater than 0. You take any value of n, any natural number n doesn't exceed 1, may be equal to 1, and it is greater than 0. So, sequence is bounded. What about this sequence? Un is equal to n. It is not bounded above, it is bounded only below, because un is greater than or equal to 1. But it is, when n increases, un increases. It is not bounded above, it is only bounded below. What about this sequence? This sequence is also bounded, it is bounded above as well as below. Say un is n, it is called unbounded sequence because it is not bounded above. And here this sequence is also bounded because n by n plus 1. It is bounded because it is n by n plus 1 is greater than or equal to half and less than 1 for all n. Verify this. Take n is 1, what do you get? 1 by 2. N is 2, 2 by 3, 3 by 4, and so on. So, this is less than 1, greater than or equal to half. Less than 1. So, it is bounded. What about n square? It is unbounded. It is not bounded above, it is only bounded below. What about this? This sequence is bounded because for all n, it is greater than or equal to minus 1, less than or equal to 1. What about this sequence? It is important. This sequence is not bounded above as well as below. It is neither bounded above nor bounded below. These are some example for sequences, and I think you followed when the sequence is bounded and when the sequence is unbounded. Bounded means it must be bounded above as well as below. Next definition is, when do you say that sequence is convergent? Very important. Sequence is convergent. See, the definition is like this. Suppose Sn is a sequence. Sn is a sequence. We say that sequence Sn tends to a limit L or converges to L. L is called also limit. Sequence Sn is said to converge to L if for all there exists m, natural number m, however large, so that mod Sn minus L is less than epsilon for all n greater than or equal to m. So I repeat, then I explain what is the meaning of this. A sequence Sn is said to converge to L if for there exists epsilon greater than 0 for every m belongs to n. Suppose m is however large, for m belongs to n, there exists epsilon greater than 0 such that mod Sn minus L is less than epsilon for all n greater than or equal to m. This is the definition. Sometimes this L is called limit of the sequence, and we write limit Sn is equal to L, or limit Sn, simply Sn is L because n tends to infinity always here. N tends to infinity. So I repeat, definition is like this. A sequence Sn is said to tend to a limit L, or sequence Sn is said to converge to L if for m greater than m belongs to n, m is however large, there exists epsilon greater than 0, so that mod Sn minus L is less than epsilon for all n greater than or equal to m. Then what is the meaning of this? What is the meaning of this? When do you say that sequence Sn converges? The meaning is, say Sn consists of, this sequence consists of infinite number of terms. That is important. Sequence means always consists of infinite number of terms. Now, if L is a fixed real number, it is. L is a fixed real number. If the terms of the sequence lies between L minus epsilon and L plus epsilon, where epsilon is positive, if the terms of the sequence, you know that Sn means it consists of infinite number of terms. Suppose for n is very large, and for that terms, corresponding to that terms, the terms of the sequences must lie between this interval L minus epsilon and L plus epsilon. Then we say that sequence Sn converges to L. Or in other words, a sequence Sn is said to converge to L if L is fixed number here, if for n increases and n becomes very large, the terms of the sequence are they lie close to each other. Then we say that Sn converges to L. I give this example, 1 upon n. This sequence un is 1 upon n. This sequence converges because what are the terms of the sequence here? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. Now here 1 by 100, 1 by 101, and so on. Next 1 by 1001, 1 by 1002, and so on. Now as n increases, these terms of the sequences becomes closer. The difference between the terms becomes small, very small, and the terms of the sequence lies between minus epsilon to epsilon. In this interval, terms of the sequence lies between minus epsilon and epsilon. Right? Therefore, this sequence converges. 1 upon n converges. Say these are all generally we are saying like this, sequence converges. But to test the convergence, we cannot use only definition. We have some other tools or some other methods to discuss the convergence. Only to explain when we say that sequence converges, I have taken this example. So when do you say that sequence converges? A sequence Sn is said to converge to L if for m belongs to n, however large, there exists epsilon greater than 0, so that mod Sn minus L is less than epsilon for all n greater than or equal to m. Meaning of this is, broad meaning is, if the terms of the sequence consists of infinite number of terms, the terms of the sequence lies between L minus epsilon and L plus epsilon in this interval L minus epsilon to L plus epsilon, then we say that the sequence converges. See this sequence Sn is equal to 1 upon n. Sequence Sn where Sn is 1 upon n. What happens to this sequence? Sn is n. Let us take Sn is n. And what are the terms of the sequence? 1, 2, 3, 4, 5, 6, so on. Correct? 6, so on. Now, sequence means it consists of infinite number of terms. Suppose n is very large, infinitely large. then the terms of the sequence, it go on increasing, it goes on increasing, and the terms of the sequence never lies in some interval. Some say n is suppose fixed number, terms of the sequence doesn't lies in this interval, L minus epsilon, N plus epsilon. So this sequence doesn't converge. Sn is n, doesn't converge. Sn is 1 upon n, converge. These are the best examples to understand the convergence, only definition, to understand the definition. Next we have different techniques how to test the convergence. We consider monotonic sequences. It is monotonically increasing. We have some rules there. If the sequence is monotonically increasing and bounded, then it converges. If it is not bounded, it doesn't converge. So we have these rules. But first try to understand when the sequence is convergent. Sequence convergent. Suppose sequence is not convergent, we say that sequence is divergent, or one more case is there, it may oscillate. Next I take divergent sequence. I hope you understand these definitions. What is sequence? In this video I explain what is sequence, some examples, when the sequence is said to be bounded and when the sequence is said to be convergent. I think this much is sufficient in this video. Next I consider some theorems. If the sequence converges, then it converges to only one number. That is called limit. Limit of a sequence is unique. I take that one in next video. Yes, thank you.